Hello and welcome to Naughty Daddy's Guide to Computing, from Maths to Minecraft. In the previous video we looked at the half adder and we noticed that if we use the exclusive OR function we can actually sum two numbers together, and if we use the AND function we can carry them. Well, that's all well and good if you've got two inputs A and B and you want a sum. I'll just draw a box, and then our output is a sum and carry. But where does this carry go? It can't go into another one because you've used up your two inputs for your A and B. If we're going to add two numbers together, you need them. So we're going to need a third input, a carry in, to make a full adder. Okay, so what do we want this full adder to do? Just fill in the other inputs, and then we want a sum and a carry out. Oops. Carry out. That doesn't look neat. Okay. Alright then, so let's draw a truth table of what we want it to do. Our inputs are A and B, and carry in. And then our outputs are sum and carry out. Oops. Cannot draw. Okay. So we're just counting up in binary to make sure we get every possible combination. So that's 0, 1, 2, and then binary 3, and then binary 4, binary 5, binary 6, and binary 7. So there's 8 possible combinations ranging from 0 to 7. Now our output, actually we really don't need that line that I drew. Okay, so our outputs, well, if all of those are 0, then there's no sum and there's no carry. So 0 plus 0 plus 1 is 1, and there's no carry. 0 plus 1 plus 0 is 1 and no carry. 0 plus 1 plus 1 is 0, carry 1. So that's basically 2. So 1 plus 0 plus 0 is 1, so that's 1, carry nothing. 1 plus 0 plus 1 is 2, so that's 1, 0, so it's 0 in the sum and 1 in the carry. So 1 plus 1 plus 0 is 2, so that's again 0 in the sum, carry 1. And 1 plus 1 plus 1 will be 3, which is 1 in the units column and 1 in the twos column. So that's sum is 1, carry is 1. Okay, so this is our inputs and these are our outputs. So what Boolean algebra can make this pattern? Okay, well, we know that we can use an exclusive OR to sum numbers together, so we've got to assume that there's exclusive ORs involved here. So if we exclusive OR A and B together and then exclusive OR the combination of that with C, let's see what we get. We'd have all zeros would be 0. A exclusive OR B would be 0. Exclusive OR CI would make a 1. A exclusive OR B would make a 1, and exclusive OR that with a 0 will make a 1. So A exclusive OR B would make a 1. Exclusive OR that with a 1, that makes two 1s, so that would be a 0. So well, there's just the 1 there, so that would be right. There's two 1s there, so that would be a 0. There's two 1s there, so that would be a 0. There's three 1s there, so that would be a 1. That's right, because A exclusive OR B would be 0, and then exclusive OR that with a 1 will make a 1. So that is correct. So sum equals A exclusive OR, well, that's a really rubbish exclusive OR. There you go, exclusive OR B, exclusive OR C. Okay, now what about this carry out? Well, that looks like an AND function. We know we can use AND, but what about these? That looks like an OR function down there, but we have to make it so that it works on all three of these variables to come up with this answer. So, and we know we use AND to carry, so what we're looking at is basically we're ORing the combination of all these ANDs, aren't we? So A and B ORed with B and CI ORed with A and CI should give us this answer. Let's just double check. In fact, let me write it down to make sure I've got this right. So let's say A and B or A and CI or B and CI. So basically, if there are any two 1s, sorry, if there are two 1s, or at least two 1s, will there be a 1 in the carry, which is what we want if we're adding these together. So that actually does look right. But let's double check. A and B are both 0, so that term goes to 0, that term goes to 0, and that term goes to 0, so the whole thing goes to 0. Okay, A and B are both 0, so again we've got A's there and a B there, so all those terms have either an A or a B in it, so yes, they go to 0. This one's got an A and a C as both 0s, so that A 0 will make that a 0, and that a 0, and that C being a 0, that CI being a 0 will make that term 0, so that will also be a 0. So in this one we've got two 1s, which is promising, so that A and B term goes to 0, but the B and CI term will be a 1, and since they're ORed, this has to be a 1. So here we've only got the 1, 1, so that means the B term there makes that 0, and the CI makes that 0, and the CI makes that 0, so this will be a 0. So that brings us down to this one. There are two 1s, so we would expect the answer to be a 1. So that A and B goes to 0, but A and CI term is a 1, so this will go to a 1, regardless of what that term does. So this one, we got again two 1s, so we're expecting it to have a 1. So the A and B term this time, that is a 1, so regardless of these other terms, it's got to be a 1. And then all three are 1s, so all three terms will be 1s, so that will also be a 1. So that is the correct formula to make a full adder. So in the next video we're going to try and draw the circuit diagram for a full adder, or rather the logic diagram for a full adder, given that we now know the Boolean expressions for a full adder.